Hi, my name is Girish, Bali, your host for today for Back to Basics. What are we going to talk about today? Are we going to talk about technology? Are we talking about problem solving? Are we talking about quantum computing or AI? They're all complicated words, but it's really simple if we go down to the basics. And this person actually has top-notched all the topics there, and she's only 15. Yeah, that's right. 1-5, not 5-0. And it's amazing how she's accomplished so much in those small time. Her name is Anisha Musti, and she has, well, you know what? Let me get to the basics when we get on her on the call. How about that? So, Anisha, how are you doing today?
Hi, Girish. I'm doing well. How are you?
Good, good. Thank you for coming on Back to Basics.
Of course.
So the first thing is before we get into the basics of the other topics, what is back to basic moment for you in business and in life? It could be one
Yeah.
answer for both. So yeah,
I mean, I think that the basics is just that when I go to school, it's crazy to see that every single thing that you learn in class just can do so much. For example, like my high school chemistry class actually applies in quantum computing. So when I started learning that, you can actually take what you're learning in school at the most basic level and apply that to orders of magnitude that are so much higher.
yeah, yeah. So that's your basic moment, huh? I guess.
Yeah.
So so Anisha, how did you come up with this whole thing? So well, you know what? Let's go back a little. You love technology, but
Yes, I
I
do.
think we all love technology in many different ways. You know, we
For
go from
sure.
PlayStations and we go to phones and then we go into computers and laptops and servers, right? But you went a little beyond that. So so explain your love and your passion for quantum computing.
Yeah, for sure. So, I mean, I've always just been a lover of technology, like you said, and only recently I've gotten to quantum, but it started when I was maybe like 8 or 9, and I got my first laptop, and then I would just start programming websites, and even for Christmas, I would start like building my own website to tell my parents what I wanted for Christmas instead of just like posting a sticky note on the fridge because I felt like that was just a much more fun, productive use of my time.
Yeah.
More recently, then someone introduced me to quantum computing, and I was like, this is absolutely crazy. Not only does it take into account technology, which is something I already love, but it also takes into account things like physics and math, which are like my favorite subjects in school. So when I found like this blend of math, physics, and technology, I was like, this is the thing for me. And that's when I started looking into quantum computing, and I've absolutely fallen in love with it. And to this day, I haven't stopped loving it. I just love it more and more every time I learn something new about it.
So let's start to the basics here. So if a person who's in middle school and going to high school or even going college, they have to be good in maths. They have to be good in something to get into your field.
Right. Yeah. So in quantum computing, it's one of those extremely cool things that you can come at it from different points of expertise. So people go and have math PhDs and then enter quantum. They have physics PhDs, then enter quantum. They have computer science degrees, then enter quantum. And at the essence of it, it's because you can't see the things on the atomic level at the quantum level. You have to do it with mathematics. So you have to be good at math to some extent, but it's not something that's unlearnable. In fact, most of the basics, which are just like calculus, are taught even at the high school level. So you can start even there.
So let me explain to the viewers and the listeners here. So quantum computing, if I'm not mistaken, Anisha, you can correct me if I'm wrong. Okay,
Yeah.
what I know is that you have one question and one answer, but in that answer, you have multiple ways to get to that answer. Is that correct?
Yeah, sort of. So the basics of it is this phenomenon called superposition. So it's a property within quantum mechanics, which is what quantum computing is based off of. And essentially, superposition is the exponential way of computation. So in a typical computer, and this is something that most people, it's like the basics of computing. You learn it in like the first lesson of your comp sci class. There's one and zero. It's a binary computation. So everything in a computer is just like a string of one zeros. But in quantum computing, that's not necessarily what it is. It's one and zero. So there's 0, 1, 1, 0, 0, 0, and 1, 1. And those four are what like makes up all of quantum computation. And when you take that, that's called superposition. So it allows you to compute at exponentially high speeds.
So, okay, so then how do we explain that to a parent telling a kid that, this is the field that you should go to? So what type of advice should we give them? I mean, it's complicated, right? So how do we explain to the parent and then to the kid that this is a field?
Yeah, for sure. So my favorite analogy is just that on a coin, there's heads and tails. But when you're spinning it, when you toss it up and when it's like spinning on the table, maybe, like it's not heads or tails. It's spinning. It's both. So in that short period of time, you can compute it at the length of which it can be either or. But it's not until you put your hand over the coin and you force it to collapse onto the table that it's either heads or tails. It's for that short period of time, it's both.
Oh, so is that how your parents actually told you? Or is
So
that
my parents,
or is
yeah, my
that
parents,
your analogy for you?
yeah, that's my analogy for me. My parents actually never told me anything about quantum computing. It's how I told them. I discovered it all through the internet and just people I've talked to. Yeah.
Oh, okay. So what are the classes that you took that it triggered you, or is it some extra reading that you did, or extra classes you took, or how does that work for age 15? I mean, the reason why I say that is because, um, let's say a person like me, it takes me so many years to get where I am. For you,
Mhm.
you just started today, so I mean, it's unheard of, really. But I'm asking. I mean, is there certain books that we're missing and not teaching my kids?
Yeah. So I joined quantum computing or just like started hearing about it when I was a freshman. So although you can learn things in high school, it's not typically at the freshman level. Though those are more like simple biology and like you're doing basic algebra. It was more extra reading on my part. So I started learning like physics at the high school level isn't really that helpful for quantum physics. It's more of like chemistry at the very end. You start learning about like quantum mechanics and stuff that actually goes into that. So I did some extra reading. I bought some quantum computing textbooks, and there's a ton of things. Even like IBM has a Qiskit textbook, so I started doing some quantum programming there, and I was able to just like read about the field.
And is
Yeah.
there like a summer camp or something that we should assign to, or
Yeah,
something?
for sure. So Q-munity, actually, the organization I run, runs a summer camp every year for 2 weeks, and we teach high schoolers about quantum computing. And it's one of the only summer camps that are specifically for high school students, so it's awesome. Yeah.
So it's only for middle to high school, or high school only?
So yeah, at the current stage where we you can apply to be a middle schooler in the camp, but we're mostly only accepting high schoolers just because of the mathematical foundations
And
that are
is there a
necessary.
certain requirement to get into that camp?
Nope, just sign up. It's everything is perfect for so the teachers are amazing. They're postdocs at UC Berkeley, professors at Dartmouth, quantum researchers at MIT, and they've made this curriculum so perfect that it could literally be taught to anyone who knows just basic addition, subtraction, multiplication, and division.
So who runs that? I mean, I think you're the founder and the the CEO, but I mean, obviously you have school and everything like that. So who runs that actually?
So the organization or the summer camp? The summer
The
camp is yeah, the summer camp is taught by the professors at these different universities,
hmm
but it's organized and maintained by our team at Community.
I see. Okay. Now regarding AI, I mean, AI is a two-letter word, but it's a big, huge topic, right?
Yeah,
So, because people, they don't realize that we use AI pretty much every day, and they don't
yep.
realize that. It
hmm
could be like you go to my website and schedule a calendar request, and that's a AI process also. Even if you call Alexa and do something else, that's also an AI process also. So, what is your definition of AI? AI, by the way, means artificial intelligence, right?
Yeah,
So,
my definition of AI is kind of I feel like most people who agree to me is just with me is pretty much just anything that simulates a human process. And for example, like the Siri on your iPhone, like that simulates a human being. Something like Alexa, the same thing. It can even be something that like detects a disease that simulates a human process because in the past, like these neural networks were like only in your brain, but now they're actually in a computer algorithm.
but are they really AI more intelligent than humans? Because technically, if you really think about it, humans are the ones who are inputting this into the AI, right? So, Do you think
Yeah.
AI is kind of doing something on their own on top of that?
Yeah, so I mean, I don't think necessarily that AI is smarter than humans, only that it has a higher processing capacity than a human does. Because everything that AI is centered around, so like these neural networks, these neural nets, they're all just like um, computational simulations of what goes on in the human brain. So it's not necessarily that they're smarter, but it's just that when you have a computer, it's really dumb actually. The computer's really dumb. Like you need to tell it everything that it does. But once you feed it that data, it can hold on to it just like a human memory, and then it can use that to make future predictions. And I wouldn't say it's necessarily smarter, but I would say that it takes a different approach to what a human using a human structure.
Yeah, I mean, take an example of the movie I, Robot, right? I mean, we kept on feeding the data into that robot, so the robot starts thinking on its own with that data.
Yep.
Is that how you example it?
Yeah, pretty much. It's like the humans are the ones doing it because the computer, like a computer with no data is really, really stupid. It's not smarter than a human, but you can make it solve answers that a human can't if you program it correctly.
Hmm. Okay, now here's a question. So, will quantum computer truly serve humanity?
100%. It's definitely not something that's going to happen tomorrow. It's a very long-term process. And there's a lot of quantum hype in the media right now, which is definitely great because it means more funding for a lot of the places that are working on quantum.
Hmm.
But that doesn't mean that it's something that we can see today. So many people say quantum computing is useless because it doesn't replace classical computers, but that's never what it was supposed to do. Like it's never going to be the next iPhone. I'm never going to have a quantum chip in my iPhone. That's not what it's supposed to do. It's supposed to solve problems that classical computers can't even begin to attempt. For example, like simulating an atom at the smallest level, that's not something a classical computer can do right now, but it's something a quantum computer can eventually do down the line.
So, I mean, there's an article that I read that you can put a chip in your eye and then have a GPS. I mean, that's gone sometimes too far, don't you think?
Yeah, there's definitely a lot of QC ethics
Yeah.
that come to the table, and that's not something that I've done too much reading into, but a lot of people are like super passionate about making sure that this is like not going to be an invasive technology, especially when it comes to things like quantum cryptography
Hmm.
that are more along the lines of like how do we break through everything in classical cryptography and make entirely new cryptography systems. That needs restraint, that needs like legislation, that needs people talking about like what this future looks like. And I mean, like, yeah, like the chip example, there's all sorts of questions like that for quantum computation as well that definitely need to be answered at some point.
So, do you think, I guess, driver's license will be minimized into one card instead of like several cards? Like, for example, you have insurance, you got registration. You think that would be part of the as one problem, as one card, I guess, as
I mean,
identity?
perhaps. I mean, I don't think quantum computers will do that, but maybe that could definitely be a future. Maybe it could be an app on your phone and you don't need any of those cards anymore.
Yeah, yeah, yeah.
There's
Okay,
no need.
so
Yeah.
regarding AI, okay, AI and machine learning,
Yeah.
are they the same or they're like interchangeable?
Yeah. So AI is this ginormous umbrella, and machine learning is actually a small part of that.
That's it.
Yeah, so there's this subset of artificial intelligence, and then there's like another subset called data, and they interlap, but in that interlap is machine learning. And
Okay.
part of that is deep learning, and then there's other things that overlap, like natural language processing and cognitive computing.
Oh, okay. That's something new that I learned on
Yeah.
that part. Yeah. So, from the, I don't know. I mean, every small company and every small business that I've seen, right? Um, they don't need AI, do they? Or do they need machine learning in their business? I mean, does everyone need it?
I
You know?
mean, need is an interesting word because I mean, a lot of them don't have it and they're doing fine, right? And it's the 21st century. So many people don't have it. They don't, I don't think they need it, but it's kind of something when some people get AI, you're going to be left behind if you don't have it because it's just revolutionary to the way your business operates. Just like implementing AI into your systems is going to, if you don't do it, you're going to be left at a significant disadvantage. And I think it's something that when the AI revolution comes, well, it's happening right now, but when it's like in full fruition, when it affects every industry, everyone's going to have it because it's just something that if you don't have it, you're just left behind.
Do you think, as a household, Do you think it's needed to turn on and turn off the light through Alexa and IoT? You think those are needed,
Right. I
or
mean, yeah.
go ahead, go ahead.
Yeah, I mean, I wouldn't say they're needed. Again, it's like the same thing, right? Like, I don't think anyone really needs Alexa. I mean, you always have Google and you can type in the answer, but why not save yourself? Like, if you have the funds, obviously, why not save yourself that time? Just put an Alexa in your kitchen. And they just have these amazing capabilities that make life and speed up so many simple processes. And that's pretty much like why you need AI. And I wouldn't say you need it in the sense that like you can't do anything without it. Like if I don't have IoT that I can turn on the lights in my entire house for my cell phone, I'll be totally fine. I can always flip the switch, but it's going to become more and more of a norm to have that like IoT infrastructure.
From the household point of view, I think the only benefit from the AI or machine learning or whatever you want to call it, I think it's more Nest, the thermostat at home, because it keeps on learning what temperature you have at home and it'll adjust. And I think that is a better machine learning for home, I feel.
Yep. Yeah,
Right?
those types of things or they just make life so much easier, and obviously there's no absolute need to have them. Like you will probably be fine if you don't, but it's just why not? It's such a way to revolutionize your life and just make
Yeah.
it so much easier.
And then regarding the AI or machine learning for cars, is that the way we're going nowadays? I think people are getting all the readings from the machine and their energy, the engine and all that stuff. You think, I don't know if the word is needed, but is that the new norm?
Right. So yeah, the biggest way that AI is being implemented in the automobile industry is just like with self-driving cars. I mean, like it existed before Tesla. There were things like Waymo from Google that were working on it, but
Yeah.
Tesla just came and made it such a sleek, simple design. And now all the other car companies are trying that as well because self-driving is going to be the future of cars, and people have talked about this for longer than we even talked about AI really. And that's the biggest implementation, but even more simpler than that, there's like things like what temperature does this person like their car at when they walk in, and that sort of machine learning. Obviously another, it's not a necessity in the sense that you can't be without it, but it's going to revolutionize the entire car industry and make life so much easier for so many people.
But I think personally, I think the electrical car is a lot better because of environment.
That too,
um,
yeah.
right? So I think right now the infrastructure is not there throughout the world. I mean, because of the
Yeah.
charging and all that.
Yeah.
But I did hear that the charging will come fast. Like you can charge the whole entire car within 15 minutes versus 45 minutes. So I
Hmm.
think that part of the process is coming.
Yeah.
So hopefully that should work as soon as I get my electrical car. Uh,
Yeah, and I mean the more people that have electrical cars, the faster the infrastructure for charging is going to come. Like if most of the population has, for example, a Tesla, then there's no really need to have just like stations for gas anymore, and those will all turn to charging stations. And
yeah.
especially like even Elon Musk has said like his vision with Tesla is not for it to be a luxury car company, and that's why like their earlier models they were definitely luxury cars because they needed money, but now once they like have that money, they have that funding, they want it to be something that everyone can afford, which is why their newest models like the Model 3 are actually more in the average price range for a car.
Yeah, I mean that's for regular people, and I
Yeah,
think it's like
exactly.
37 or 35
Yep.
thousand. So I mean that's a decent amount of car price. So I think other manufacturers are doing it too. I think BMW is doing it, Audi's
Yep.
doing it. So I think slowly everyone is just expanding. I think Honda's doing it. I think so.
Yeah,
I
for
think
sure.
it's just gone massive on that part. So what about planes? Do you think planes we're going to be doing that, or are we still going to be still in that fuel mode?
Yeah, I mean, I'm sure. I'm sure they'll figure it out because I think the world is becoming more climate conscious, especially just
Yeah.
of what these fossil fuels mean for our environment, and especially because now we're coming to a brink, right? And we're hitting that 2 degrees Celsius mark, and people are like, it's a wake up call. This is happening right now. Climate change is not fake. Like, yeah, it still snows in New York, but that doesn't necessarily mean that climate change isn't real. And so I think that it's probably I do envision that like a lot of industries are going to start thinking about ways to switch out of fossil fuels, and personally, I don't know much about how planes operate, so I wouldn't be like the best person to speak on how they're going to do that, but I would probably say that that would be a conversation that they'd have at some point.
So besides all this technology stuff and the quantum stuff and the machine learning, I think I've read somewhere that your free time is playing hockey and hanging out with family. Is that after all that, do you still have time for all that?
Yeah, for sure. I mean, my kind of philosophy is that if if you can't make time for something, it doesn't really matter to you. And something that does matter to me is my family. It's playing hockey, and those are things that I've done for so many years, and they still matter to me so much that if I'm not making time for them, it means that they're not important to me. But yeah, I do play hockey. I play it for my school team in the fall, and then I play it with my friends throughout the year, and I always make time to hang out with my family. Yeah.
So and what are the things? Well, okay, let me start again. Do you still do the 15-year-old things that people do around there? I mean, it seems like you're doing so much. Sometimes don't you miss it sometimes for the regular things going on in the world?
I would still say that I do most of the regular 15-year-old things, and most people, and I obviously there are times when like I'd have to miss like a school bake sale or something because like I'm doing something else, but for the most part I try to make a conscious effort to like still hang out with my friends. I still like go to birthday parties, I still play hockey. I'm on my school's debate team. So all of these things, they still are like a huge part of who I am outside of just like a technology lover. And yeah, they matter a lot to me, so I always try to make time for them.
Yeah, that's good. You should be grounded and go to the back to the basics of where you all started. I mean, yeah,
Yeah.
family is important, but this
Hmm.
is also as important too. So how do you balance your life? And I
Yeah.
think you're doing it beautifully, and it's amazing how you have grown. So usually my guests are much in the mature age level. So my usually questions at the end of the episode is, what are you going to do for the next 5 years? But what I'm going to ask you is, what are you going to do for the next 5 and 10 years? Because your 5 years is age 20.
Yeah.
So I'm going to ask you that.
Yeah, I mean, 5 years, I see myself in the middle of college, right? I definitely want to go to university. I want to get that structured learning time. And I don't see school as like an excuse to wait on doing. Obviously, like you can do whenever, right? Like age is not a barrier to doing, but I do love learning. And I think for a lot of the things I do and I want to do in my future, I think having that 4 years of just going to classes, learning even more than I did in high school is just imperative.
Hmm.
And yeah, maybe if university, if I hate it, if it doesn't work out for me, if I'm like, I don't really enjoy this learning that much, then like, why not drop out, right? But that's another thing that's like, at least give yourself a chance to have that structured learning time. So that's where I see myself in 5 years. In 10 years, I would be 25. So ideally, I'd see myself starting a startup in whatever I really feel passionate about at the time. Maybe it's quantum computing, maybe it's artificial intelligence, maybe I found some new interest, maybe it's brain computer interfaces, whatever it is. Technology, entrepreneurship, those are things I love, and that's kind of where I see myself in the future. Maybe I start working at some other tech company and then this happens when I'm 26, but yeah, somewhere around that time frame is kind of just where I see myself doing that.
Well, thank you so much for coming on my show, and it's just so inciting that at age 15, I think what I think is going to be so inspiring for youngsters, whoever is listening to this podcast and this video, that whoever is going to watch, and it'll be so insightful. It'll be great for even parents that they didn't realize that there are other things. I mean, yes, people, they say doctors, lawyers, IT, but then they don't realize what's inside the IT. And I think we explored that today. And I think that's a different avenue for a lot of people. So I
Yeah.
thank you for that, for coming. So one last word before you leave today for Back to Basics.
Yeah, for sure. I mean, the biggest message that I like to share is just never use age as a restriction. Like if you have a passion, if there's something you want to do it now. Like don't wait. Um, if you're coming out of college and you're like, oh, I'll do it then, life gets in the way. So why not start today? And age, never a barrier.
No. Well, Anisha, thank you so much for coming today. And thanks for giving us a little insight to this.
Yeah, of course. And thank you for having me.
Thank you. So, guys, we had Anisha today at our episode, and she has taught us a lot in this episode. And I hope that you will comment, and good comments or bad comments, either way, it will make my show much stronger. So, either way, just comment and give us feedbacks. So, at the end of the episode, I always give you a quote, and the quote is "Quantum attention functions are the key to quantum machine learning," and that's by Amit Ray. Um, if you go to his website, I think when I navigated, he'll give you the rundown of 101 of quantum computing. And I think that gives you a good rundown of what that is. And as always, as I say, everything in life goes back to basics. And that's what we did today, guys. Thank you, guys. Enjoy your day and God bless. Next week's episode on Back to Basics. Do you know henna is considered harmful for the skin?
No. No, henna is actually good for your skin. Like a lot of cancer patients, so henna is colder for in nature. Like it's cooler for in nature. So like a lot of cancer patients when they go for chemotherapy, like they because they lose all hair and so.